Joining me in the studio today is Professor Christian Drosten, a specialist on viruses, and he has been involved in the BAD project too in Ghana. Now, Professor Drosten, what actually has to happen for a virus, which is harmless in bats, to become a killer for us humans?
Well, this is actually the subject of our research there. So this is the motivation to understand these mechanisms. There are some examples that we can mention. For example, we know with influenza virus that certain genomic segments have to be exchanged when two viruses hit the same cell. But this is just a detail. There may be other concepts, such as, for example, herd immunity. So if we, as adults, are immune against our typical human viruses, this is the normal situation. But when a novel virus comes and hits the human population from an animal reservoir, it meets a totally open field. So it can spread in an uncontrolled fashion because nobody has ever seen this virus.
And if we change the perspective and look at it through the eyes of the virus, I mean, what's its optimal strategy? Is it to be a killer, completely lethal, or would a virus not just kind of prefer to leave its new host alive?
It depends a bit on the biological situation. In this situation, when you have an epidemic, the virus is just happy it can spread. I mean, a virus doesn't think, it doesn't feel, it's just replicating. And what we see, the viruses we see are always the winners of an ancient battle. So in an epidemic, yes, it is a very rapid process, usually. But then afterwards, if the virus stays and if it's already killed or affected a certain fraction of the population, then more sophisticated biological mechanisms come to play. For example, persistence. A virus then has to somehow tune down its own virulence. It's,
for example, like a cold virus.
Yes.
We have. I mean, do all the viruses we have come from animals?
Well, I mean, it's difficult to give a very general estimate here, but the more we learn about virus evolution, the more we can say probably yes. So there are viruses for which we even know a date when the host switch has happened. There are viruses which are quite recent, so say 100 or 200 years ago, they entered the human population, and we even know their most probable origin. And there are viruses that are quite ancient.
I understand. So, but we probably have to assume that out there are millions of viruses in animals just waiting to attack us humans. What do? We can't eliminate all the bat populations. So what's the strategy?
Well, the big dream actually in this field of research is to be able to predict. So you can compare this a little bit like the weather. You can't change the weather. We also can't change the viruses that are there. But maybe we will be able to say this is going to be a dangerous region, a dangerous virus. We should be careful not to come in contact with this animals or with this forest.
So we can be prepared.
Yes.
Thanks a lot for the talk, Professor Drosten.